We spend approximately a third of our lives asleep, which means if you're lucky enough to live to 100, roughly 30 of those years you are in a deep, deep slumber. And if we do something this much, it's important we understand what's happening in the mind and body. In other words, how does sleep work? Alright guys, welcome to Psych Explained. In this video, we're going to dive into sleep. Specifically, what happens in the brain to produce the onset of sleep and what happens during a long night's sleep. So let's start with this question. How do you know when to go to sleep and when to wake up? And you might be thinking, well, I have a clock that lets me know. But what if I told you you didn't need a clock? That instead you have an internal clock already that lets you know when you're tired and when it's time to wake up. And we do. And that clock, and we'll write that in together, is called your circadian rhythm. Okay? And the reason we call it your circadian rhythm is because it's Latin for circa, which means approximately, and diem, which means day. So approximately during a 24-hour period, your body is scheduling when to wake up, when to go to sleep, when you're hot, when you're cold, when you're hungry. It is the schedule that you already have. Now, what controls our circadian rhythm? Well, what controls our circadian rhythm, and I have a moon here, is information from the outside world, specifically light and dark signals. So let's walk through together how this may work. Let's imagine it is 11 o'clock or midnight, right? And you're getting into bed. How are we going to feel tired? Well, the first thing that's going to happen is light is going to hit the eye. And the eye is really what tells your brain whether it's time to go to sleep or not. And this information is going to hit the back of the eye. What do we call the back of the eye? This is the retina. And why is this important? This is where light converts into electrical impulses or action potentials. And this electricity is going to travel up the optic nerve. Okay, this is made up of ganglion cells. And it's going to reach a really important part of your brain that regulates your entire circadian rhythm. What part is this called? This is your hypothalamus. Let's write that in here. Your hypothalamus. And why do we call it your hypothalamus? Let's do a little error right here. Because the word hypo means below. It is below our thalamus. And your hypothalamus, I like to think about it like your internal thermostat, right? It makes sure that your body maintains homeostasis. If you're hungry, you eat. If you're thirsty, you drink. If you are cold, you got to get warm. And if you're sleepy, you got to sleep. This is why it's so hard to stay up when we feel tired. And if you're driving, you know that feeling. So this is our internal thermostat. Now within our thermostat, within this hypothalamus, is a group of cells that really regulates this entire circadian rhythm and gets the things in motion to produce sleep onset. And what is that? It is a tiny group of cells within the hypothalamus called, this is a big one, your suprachiasmatic nucleus. Let's write that in together. Your suprachiasmatic nucleus. Okay, nucleus. Or, and this is much better to abbreviate, your SCN. And your SCN is going to communicate to the rest of your brain, different parts of the brainstem, different parts of your glands, that it's time to go to sleep and produce different hormones and different chemicals. So where is it going to go? Well, the SCN is going to communicate to really two parts, and let's think about this together. The first one is a major gland in your brain called, and we'll fill it in here, your pineal gland. What is it called? Your pineal gland. Pineal, raise part of the brain there, pineal gland. And that is located right here, okay? Shape of the pine cone, and that's why we call it the pineal gland. Now, what does your pineal gland do? And you probably know this word because you can buy it at a pharmacy. It's going to produce or secrete a major hormone that's going to start slowing your heart, your breathing, your temperature, and produce sleep. What do we call this? We call this melatonin, okay? So we're going to start produce melatonin, okay? So that's the first part. Your SCN controls your entire circadian rhythm, right, through light and dark signals from your eye. And it's also going to control and tell your pineal gland to start releasing melatonin. Your SCN is also going to communicate with, right down here, your brainstem. Okay? Now your brainstem kind of does a few things, right? Your brainstem's kind of that middle pathway, right, between the body and the rest of the brain. Everything's going to flow through the brainstem to go to the cortex or to the lower part of your body. But your brainstem also controls a lot of other things. Because if you damage your brainstem, you might go into a vegetative state or a coma. That lets us know it definitely plays a role in arousal and sleep. Now, are there any specific structures within the brainstem that help with sleep and alertness? And there are. Let's talk about a few of these. The first one is this band of fibers that runs up the brainstem, just like this. And it's got all these fibers attached to it like this, okay? And it's gonna talk to the thalamus and the rest of the brain. This is called the reticular activating system, or the reticular formation, okay? The reticular formation, and that is this structure right here, all right? And what does it do? Let's write a few things down. It is involved in arousal, okay? It's involved in consciousness, okay? Consciousness. And we know that because if you damage your reticular formation, you will fall into a vegetative state or coma, okay? And of course, sleep. So what does this have to do with sleep? Well, as melatonin is being released and your brainstem is getting ready, what's going to happen is your reticular formation is going to be kind of like a shutoff valve, right? Information likes to rise to the cortex, that's the wrinkled layer, to think and make decisions. But we don't want that when you sleep. We want some sort of off switch. And that's what your reticular formation is going to do. It's going to kind of produce that off switch, okay? So information is not going to reach the cortex, so we're not thinking. It shuts off that arousal. It shuts off that consciousness, right? So there's the first part. That is our reticular formation. Now we also have, and we'll talk about this a little later on, our pons, which is this structure right here. It's a little bulge right above the brainstem. And our pons, what does it do? It plays a role in muscle relaxation. Okay, muscle relaxation. So when you are in relaxation, when you are in REM sleep, we'll talk about rapid eye movement later, your body is paralyzed, right? Your pons plays a role in that as well. So this is a nice anatomy, a nice way to think about what is happening in the brain. Now, are there neurotransmitters involved? Of course, right? Serotonin is going to decrease. We don't want to be alert. Dopamine is going to decrease. We don't need pleasure reward when we're sleeping. Acetylcholine, which controls muscle movement, that's going to decrease. We don't want that. But is there something that's going to increase? And there is. So what's going to increase? Your brainstem area is going to produce a chemical called GABA, or gamma aminobutyric acid, okay? This is a major inhibitory neurotransmitter. What does that mean? Your cells like to fire, right? Neurons are communicating to each other. We don't want neurons to communicate to each other. We want you to go to sleep. So what's going to happen is GABA is going to flood your brain. It's going to flood everywhere and inhibit or stop things from talking to each other. So if I put a little, if I have my little stop sign right here, where is this going to take place? Well, we definitely don't want you thinking, right? We don't want your prefrontal cortex working. We don't want your reticular formation to work, right? We want that to stop with arousal and wakefulness. We don't want your hypothalamus to talk to things, right? So you have all this GABA all over the brain telling everything to stop working. We want neurons to stop firing, and this is going to occur everywhere. We'll put one there as well, right? So GABA is our main inhibitory neurotransmitter. Now here's the question. Now that we know what's happening neurologically, what happens during a 7 or 8 hour night's sleep? And how do we know what's happening? Well, let's take a look here. The reason we know what's happening is because scientists, quite amazingly, can peek into your brain as you sleep. And yes, I know it sounds like science fiction, but we can actually do that. And the way we do that is with this little machine right here. Now, what is this called? Once again, a big word just like the suprachiasmatic nucleus. This right here, this little machine, is called the we'll break this up, Electroencephalograph. Woo, that's a big one. Or, and this is much easier, just like the SCN, we're going to call the EEG, Electroencephalograph, or you might see the phrase electroencephalography, right? Now, what does this machine do? It's measuring the electrical activity in your brain. Right? When you're sleeping, your brain isn't shut off, right? It's not an on-off switch. It's still highly active. And your brain communicates with electrical impulses, right? Action potentials. So what this machine does is it captures and monitors all that activity that's happening in your brain. And what we find is that at every stage of sleep, of let's say 8 hours, you're going to produce different types of electrical activity. So we're going to put all these electrodes on your brain. I've actually had this done. I had sleep apnea when I was younger, and they put all these little kind of metal discs on your head, and these are going to be attached to a computer. Okay, so all these are going to be attached to a computer. They're going to glue them on, and yes, it kind of feels weird when they come off. Okay, all these are attached. We'll get each one of these electrodes to a computer. Okay, and what it's going to measure is all this electrical activity, and it's going to chart it out on a graph. So what we're going to do in the next segment is understand what's happening during the sleep cycle, what kind of waves is it showing, and what are the stages of sleep that we see on an electroencephalograph. Now, the first thing to understand is there's actually 2 stages of sleep. We'll dive into this and how this works with the EEG. We have REM sleep and non-REM sleep. What's the difference? REM stands for rapid eye movement, which means during the 1950s, there was a really good discovery at the University of Chicago that when you're sleeping, your eyes are moving rapidly under your eyelids. That's one stage. The other stage is any stage in which your eyes are not moving. We call that non-REM sleep. So there are 3 non-REM stages and 1 REM stage. Okay, so we'll dive into that as well. All right, so let's start with the first one, okay? What is happening? Well, let's say, and we'll stick to our scenario, it is 11 o'clock. And you're about to go to bed, but you're still alert, okay? Well, right now, you're awake. So there you are, okay? And if I put an EEG on your head, what you would see, and I'll use a different color here, are things called, I'll write this in right here, beta waves, okay? Beta waves. And beta waves look like this, okay? And what does this mean? High frequency, high frequency, low amplitude, okay? And, frequency refers to peak, right? Every wave is very close together. There's our frequency. And our amplitude is the peak, right? How high the wave gets. So when you're awake, you're listening to me right now, your brain is producing what? Beta waves, okay? So that's the first part. But then you start getting tired, okay? And you start getting drowsy, more drowsy, and your brain's actually going to start producing alpha waves instead of beta waves, right? All this is from the Greek alphabet, alpha, beta, gamma, delta, so forth. And then what's going to happen is you're going to enter what we call non-REM 1, right? So your eyes aren't moving. This is considered stage 1. What's happening in this stage? Well, first, let's draw some of these brain waves, okay? And they're going to look something like this, okay? Very similar to being awake, okay? You have high frequency, low amplitude, and we'll do it down here. These are called, I'm going to use a different marker for this. This is going to be called theta waves, okay? Theta waves, okay? Now, this is a stage of sleep where, like, people are sleeping, but you're not sure if you're sleeping. Do you ever have that? You wake up and you're like, was I sleeping? You were probably in non-REM 1. So because of that, we like to consider this light sleep, okay? Where you're kind of sleeping, you're kind of dozing in and out of consciousness. It is considered light sleep. Now, there's other really cool things that happen. One, in non-REM 1, you might experience something called hypnic jerks, okay? And as a teacher, I experience this all the time. Do you ever have that moment where you're like this? Oh, right? And you just wake up, your head jerks up. Oh. And I love my students. They're like, oh, they do this, and they look around. I'm like, hypnic jerk. It's a muscle twitch, a muscle contraction that happens when you are non-REM 1. Another thing that happens during non-REM 1 is something called, and this is a big one, hypnagogic hallucinations. Okay? And a hallucination is kind of, hallucinations is essentially kind of a false sensory experience, right? You might hear a voice that's not there. You might see something that's not there. I ask my students, I'm like, how many of you have seen a ghost? Everybody's hand goes up. How many of you have ever seen a ghost during the day? Nobody's hand goes up, right? People only see ghosts at night. And that might be because it's during non-REM 1. You hear things that aren't there. You see objects that aren't there. Your mind is kind of hallucinating because you're in this weird transition period between consciousness and sleep, or wakefulness and sleep, right? All right, so there's non-REM 1. What happens next? You're going to keep transitioning down away from wakefulness, away from light sleep, to what we call non-REM 2, okay? What happens in non-REM 2? Let's start here. First, you still experience theta waves, okay? Theta waves. But then something also happens. right? Your body temperature's dropping, your heartbeat's dropping, your breathing's dropping, or everything is slowing down, your muscles, etc., is you can actually tell you're non-REM 2 because of two things on your EEG. One is called, and we'll draw this together, sleep spindles, okay, sleep spindles, and the other one is called K complexes, okay, a complex and a sleep spindle. So what would this look like? We have our brain waves, still high frequency, low amplitude, and then what happens is you have these brief bursts of brain activity, okay? So it's like go, 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 and then right, a lot of activity in the brain, okay? And then, by the way, that's a sleep spindle. You have a K complex, which is this high, amplitude, kind of this high delta wave, followed by a big drop, and then returning to high frequency, low amplitude. So here's our sleep spindle. I'll do SS. And here is our K complex. And there's some theories about why we have spindles and complexes. And one of the theories is that if we go back to the brain structure, information is trying to enter your brain and wants to wake you up. But your reticular formation, your thalamus is like, no, 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 we still need sleep, right? So this kind of information entering your brain and your thalamus is like, no, 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 we still need to filter it out. We still need to sleep, right? So there we go. We're non-REM 1, non-REM 2. What's going to happen? We are continuing our night sleep and we enter non-REM 3. This is a good stage. Non-REM 3, if we look at a brainwave, you tell me what difference you see. Okay, what difference do you see in the first two? Okay. We have low frequency. The waves are really far apart. And instead of low amplitude, we have high amplitude, much more stronger, right? So the waves look very different. This would tell a scientist or a doctor looking at you, they'll say, oh, you've entered deep sleep. So let's write that in together. We have theta, theta. We are now into what we call delta waves. Okay? Delta waves. And once again, delta waves are low frequency, high amplitude. Another way to think about deep sleep, non-REM 3, is instead of we'll call it deep sleep, by the way. Deep sleep, you can call slow wave sleep. So we have deep sleep, also known as slow wave sleep. Okay? Right, this is the type of sleep where it's impossible to wake up, right? You feel like you're a zombie. You can't wake up, right? You're just dead to the world. This is deep sleep. It is very hard to wake somebody up in deep, deep, slow wave sleep. Now, other things happen during deep sleep. One is we know growth hormones are released, right? Body's going to repair itself. So we know at different stages of sleep, different things happen. Your cells are going to repair themselves. Your body's going to get better. That happens during deep sleep. Also during non-REM 3 is parasomnias or sleep disorders. Okay? A lot of sleep disorders are going to happen in this stage of sleep. Things like sleepwalking and sleep talking. Sleepwalking, we talk about as somnambulism is the technical name. Bedwetting, right? All those things happen technically or during non-REM 3. Okay? All right. What happens next? Something magical happens. Instead of just waking up, right? We start to go back to the original stages. 1, 2, 3, and we go back up. You go to non-REM 2 and all the way up. Okay? What happens next? Right before you wake up, something happens. Okay? What happens? REM sleep. Rapid eye movements. Your eyes are going to start moving rapidly under your eyelids. Okay? What does this look like on our little EEG? The waves are going to look like wakefulness. Okay? They're almost going to look like theta waves like up here. Okay? In other words, your brain might not know the difference between being awake and being in REM. It almost looks identical. Now, what does this mean? Why is rapid eye movement so important? Well, one, we find, and scientists will find this out in the 1950s, that this is typically when we dream. Now, yes, you can dream in non-REM sleep, but majority of dreaming occurs in REM sleep. So when you see somebody's eyes moving back and forth, wake them up. They're likely to remember a very vivid dream during REM sleep. All right, what else do we know about REM sleep? We know that also you have muscle paralysis. Your muscles don't work. Okay, you're paralyzed. Muscle paralysis. Okay? And a lot of people will say, paralysis. I've woken up during REM sleep. And you're aware of the world, but you can't move your muscles. Of course, because your muscles are paralyzed, right? You don't have acetylcholine, you can't move, and things like that. All right, what else do we have? Another way to think about this, and this is a big phrase as well, is paradoxical sleep. Okay, it's like a paradox. This is another name we use for REM sleep. Why is REM sleep paradoxical? Because it doesn't make sense. Your brain is highly active, you got a lot of activity up there, but your body's paralyzed. It's a paradox, right? So you have this irregular heartbeat, your breathing's irregular, your temperature starts to change, right? Everything's changing, but you're paralyzed. So that's what we call paradoxical sleep. All right, anything else important about REM sleep? It is also important in memory and learning. In other words, if I deprive you of REM sleep and you learned something the night before, you might have trouble remembering it the next day. So rapid eye movement is important for dreaming and memory and learning, and we know our body's paralyzed, but our mind is active, hence paradoxical sleep. Okay? All right, let's continue this. What happens during night? Everything's going to keep going, right? We are going to go back down to stage 2, stage 3, right? And then we go back up again, right? And by the way, each one of these cycles lasts about 90 minutes, about an hour and a half for each cycle. And we go back, and right before you wake up, back into REM sleep, okay? And notice also is my line is getting a little bit longer. In other words, as the night goes on, you spend more and more time in REM sleep. So at the beginning of the night, little REM, at the end of the night, a lot of REM. And we go back, and we're going to go up again. And notice also, you spend less and less time in deep sleep. A lot of deep sleep in the first half of the night, less deep sleep later in the night. So a lot of REM, okay? And let's just, for imagination, we have one more. And then, boop, we'll say you have a big REM moment. You spend an hour in REM, and then you wake up. There is a perfect night's sleep. And I like this kind of graph here. You can kind of see that deep sleep decreases as you get through the night. And of course, longer REM moment. Now, this is a perfect night's sleep, right? Not everybody has a perfect night's sleep, but that would be one. All right, guys, thanks for watching. I really hope you took something away. Don't forget to like the video, subscribe, and I'll see you next time. Oh, and most importantly, get some good sleep.